Hey, how's it going? So today I was planning to do the Kickstart round, but I didn't wake up early enough. So instead, we're going to try something a little bit crazy. We're going to see if I can finish the round in under 10 minutes. That would be crazy because William Lin here won the round, and he took 32 minutes. And I mean, I have beat William Lin before, but not by this much. So let's just get into it and see what happens. All right, so first problem here. Okay. Try to start this. So we have D and C. So it's NDCN, so it's C, yeah. Okay, and then how's this? Okay, so you kind of just see how long you can go and see if that covers all the dogs. It makes sense. Kind of a weird problem. Alright, and here's a string. So we got 2, and then that's the number of dogs that we actually have. Let's subtract the number of dogs to 8. And yeah, basically, if each character, if it's a cat, then C is not positive, we'll break out, otherwise we'll just subtract. And dog will also break out, otherwise minus minus, dog's 8 plus plus, and C plus plus N. And that's basically it. And we're just doing 8 is equal to dogs, yes, no. So let's just check on here. Yes, yes, no, and yes. Okay, so that looks good. We can submit. Submit. I have to pick language. Alright, there we go. We're going to move on to staying hydrated. Okay, Manhattan distance. Oh, we just need to find the. Okay, you just want to minimize the total distance of the. Oh, wrong answer. Okay, it's not a good sign. Yeah, even solve the first problem. Let's see, what could be wrong here? So, we have the total number of dogs. Checking dogs to 8. We ran with cat food, we fail, or we break out. Otherwise, we do that. We run with dog food, we break out. do this. Oh, is it? Oh, it's overflow. Oh, it's awful. Okay. Because, yeah, you can reach 10 to the 10th. That's very annoying. Yeah, they actually set up these numbers so that it was just big enough to mess you up. Alright, so 2 minutes left. You can probably get the second problem. Yeah, I think you just find the median, but... Oh, wait, what is this? Oh, this is different from what I thought it was. Okay, the overflow was the issue. Fixed it. Yeah, actually, so we can still solve it independently for each coordinate. I think that the median thing still works. And I don't have time to to finish this. Let's see. Yeah, I think the median thing still works. I already ran out of time. Let's use a 10th element, which will be nice here. And yeah, we're just doing this. Okay, yep. Now we're in practice mode, unfortunately. So the answer was I cannot finish the entire problem set in 7 minutes. But alright, that one is done. Let's just keep going. If you have any other bunches, so they're in a line. Okay. So cost 2 contiguous sections. Okay. Let's see. Okay, so we got that. We got both of these, and we focus on this one. Total number of bunches equals capacity K. Sheet exactly? That doesn't make much sense. I see, so n can be up to 5,000, k can be up to 10 to the 6th, so 5. Okay, so oh, the b's can be 0. That's a bit weird. Okay. Say we iterate over what the second segment is, then we know what the first segment needs to sum to. Ah, yeah, this is what we do. So yeah, we know what the first segment needs to, so we just have a min. And then we say the first segment can be empty, but the second segment cannot. Okay. And no. We are actually in danger of overflowing again. So it's that. I guess technically we can do this, and then there's no reason to risk it. I'm actually not 100% sure we'll need this, but we can just create it. Okay, and then, yeah, so basically, we need two things here. So first we're going to update segment ending at I, and then also we need to know the min cost of each sum. Or sum is going to be perfect sum. Oh, this needs to be, yeah, perfect sum. X, and then if sum is less than k, then cost sum with I minus x. And now, yep, we're going to go here. Basically what we have is g minus 5 plus min cost of k minus 7. And I think that's it. Oh, got 4 for this one. How did that happen? Ah, because this. Okay, good thing we caught that. I think we're good now. Okay, cool. Submitted. And that's a problem. 2 integers, in the area A. So pulling out the area is exactly over 2. Ooh. I think the area is at least n divided by 2 minus 1. Just n minus 2 divided by 2. Right. This is one of those problems that I probably need to draw something. And unfortunately, I don't have a pen in front of me, so I'm gonna go find one. Okay, and fitting with a theme, I found an old Google pen. So. So A is up to 10 to the 9th, right? We're all good. Yeah, I think this should work. So I'm just gonna make a zigzag, and then the last one is gonna do all the remaining area. The answer is A has to be at least n minus 2. I think that's it. This one is this. Over here. As it's possible, and we just get the points. So And now we have our last point. And what we need is, let's do this. And what we need is just a minus 3. Yeah, so if a were equal to minus 2 exactly, it would be 1. And yeah, basically, well, this is actually pretty straightforward. I think if n is even, we're adding to x, or we're adding to y. Alright, and then we're just going to print all the points. So let's try that. How did need become... Oh, wait a minute. Oops. It should have been 35. Need is a minus n minus 3. Isn't n minus 3 1? Now I'm confused. 35, yeah. So, oh, because we, I see. Oops. No, that's wrong. I think this looks good. Yeah, that's just good to go. So what would have been our time? Hold on, 16 and 40 seconds. I think we had 7 minutes of the start, so that was 23 minutes. Sample file. Why is that a sample field? Oh, I need to build it in the other order. Okay. I understand. So there's lower and upper. Yeah, and basically upper, otherwise lower. Let's see, which one is this? Oh, it actually doesn't matter, does it? Yeah, we just want it to be in the middle. Okay. 1, 0. 36, 1. We need to print upper and reverse. Okay, let's try again. 1, 0. 36, 1. 1, 1, 0, 0. 1, 0. 2, 1. 2, 35. 1, 1, 3, 0. Okay, we'll go there. Alright, let's. Oh, this is not what I want. Like this. 18. Okay, so I think almost 19 minutes. 19 plus 7 would be 26 minutes. And I think the sample failed is not a penalty. Ah, wrong answer. Okay. Okay, so I think we didn't win the round. Hypothetically. I really like to test this. So 3 to 5, it worked. How is it possible that it worked for 3 to 5, but not? Oh, you can't make a straight angle. Oh. I'm making a lot of straight angles. I see. I should actually fail the first. Oh, I did fail the first step. I see. Okay. Well, that's what I get for not reading the problem properly. Okay, but now I can just do it in a zigzag. I think that works just fine. Yeah, that works. This is probably just kind of annoying. I have to code up these cases. x is going to be it's just going to be 1, 0, 1, 2 of I mod 4. Can I not do this? It doesn't like that. Okay. And then y is just going to be, there's actually just I divided by 2. Right, left, left, right, left, left. So I do want that actually. So if y is 1, not yx, if x is 1, we're just going to increase the y. Now we really just do this, and then side which back. This is 0 and this 2. For 0, we're just going to do this. And for 2, we're just going to do this. Yeah, cool. And now we just gotta make sure everything's in range. I think the only way to end up out of range is this is what we're going to add to everything. Okay. Zero, 0, 1, 1, 2, 6, 1, 1, 1. That works. Zero, 0, 1, 1, 9, 2, 1. 6, 0, 7, 1, 0, 2, 1, All right, let's just do it. Is it a good sign that it's running for a long time? I don't know. This is actually a very long time. Should be very fast. Maybe their checker is slow. Should I refresh? Oh, look at that. All right, got it. I think this would have been good enough for third place. Yeah, that looks right. Because my penalty should be basically something like 44 minutes. Yeah, that's right in third place. Cool. Let's put the problems. Okay, I've got to run soon, so I'm just going to give really quick explanations to each of these problems. So first problem, dogs and cats. This is a pretty simple problem. You just simulate, it's really about understanding what they're asking for and then simulating the situation here. Yeah, basically I just get the count of total dogs in the string, and then I track how many dogs who actually did eat, and just again go through the strings, simulate the process. If we ran out, we have to quit. And then here I track the number of dogs who ate, and this is the when a dog eats, we get more cat food condition, which is specified here. Kind of a weird setup, but yeah, you just go with it. And the one gotcha that got me, unfortunately, is 10 to the 4th times 10 to the 6th is actually big enough to overflow 32-bit. So you need to use 64-bit integers. All right, so that's the first problem. Second problem. This problem is actually kind of hard. It ends up being a really simple solution, but you need to do some thinking to get there. And I wonder if a lot of people who got this problem ended up just guessing how it works. But basically, you want to have the minimum. You want to find a point that has the minimum total distance to all of these rectangles. Because it's Manhattan distance, you know, it's absolute of x1 minus x2 plus absolute value of y1 minus y2. We can just separate out the x and y coordinates and solve them separately. So let's say we're solving an x coordinate. Well, then for any rectangle, you know, from x1 to x2, then any x coordinate between x1 and x2 has a cost of 0. If I go to x1 minus 1, I have a cost of 1. If I go to minus 2, I have a cost of 2, 3, and so on. Same thing, if I go to x2 plus 1, I have a cost of 1. x2 plus 2, I have a cost of 2, plus 3 is 3, 4, so on. And the trick that I found is that this cost function is actually pretty much equivalent to absolute value of x minus x1 plus absolute value of x minus x2. Because for that function, it looks like this. For that function, anything in between x1 and x2 is going to have a value of x1 minus x2, or x, I guess we don't need to add. This is going to be the value. That is the min. And then when you go outside of the range, for every step outside, you add 2, because you get one farther from each. And so this looks a lot like the previous function, whereas the previous function looks like something like this. And now our new function, sorry, that should not be negative. This is the cost function in the actual problem. And then if you use this function, it looks something like this instead. These are all going to be 4, 4, 4, 4, 4, and this is going to be 6, 8, 10, 12, and so on here. 12, 10, 8, 6, and just make this up a little better. And if we think about this, then yeah, this is actually just a linear function of this. So minimizing one is the same as minimizing the other, and minimizing the sum of a bunch of one is the same as minimizing the sum of a bunch of the other. So that's why I think this problem is kind of hard. You have to like figure out this weird condition. And yeah, what you end up doing is you just take the median of the x coordinates and you take the median of the y coordinates. And because they ask to minimize the coordinates, you take the left median instead of the right median. And then that's it for the problem. But this kind of explanation and thought process is actually pretty hard. All right, third problem. We got to get exactly a sum of k with at most 2 contiguous segments. So what I do is I just loop over the second segment in order of its start point. And then if we pick our second segment, right? We know its sum, so we know the sum that the other segment will need. And if we knew, for this prefix of the array, what is the minimum number of items to get the sum, then we would be done. And so that's actually what I do. I just create this array, mincost, which tracks every sum from 0 through k, and that's okay because k is not too big, it's only 10 to the 6th. And for each I is the start point of the second segment. So now for each I, as we're increasing I, we need to add a bunch of first segment candidates, and that's what I'm doing here. So these are segments from x to I. These are the new segments that we need to consider. Add them into our array as options. And then this is choosing our actual second segment. So when we choose I to j, we know the sum here, we know the sum that we need from the other one, and we just plug it into mincost. So pretty simple, just n squared, and I guess n squared plus k, because we have to make this array. And yeah, that's it for this problem. And then finally, the last problem, we need to make a simple polygon with n vertices with area a over 2. The first idea is that a has to be at least n minus 2, otherwise it's definitely not possible. And then the other thing that I do, yeah, the construction that I do basically looks like this. I guess I could do some ASCII art here. So it looks like this. Oops. So this would be a triangle, and then if I have 4 points, I'm going to go here. Then if I have 5 points, I'm going to go here. If I have 6 points, I'm going to go here. I guess I need to make these as well. So, okay. So this is the triangle. And now if I have a 4th point, I'm going to put this point. And now it's actually going to look like this. And now if I have a 5th point, I'm going to put this point. And now it's actually going to look like this. And then if I add a 6th point, I will go here, and it is going to look like this, and so on. So it's basically here, then here, then here, then here, then here, and then here, and then similarly it'd be here, and then here, then it'd be here, and then here, and so on. And that's, I'm just making this kind of zigzag pattern, right? And then each time we add a new point, we're adding 1/2 area, so we just add one little triangle. And then finally what I do is, on the last point, I add a really long triangle to get the area that I want of A. So here's an example here. This would be our next point. But if instead I need a bunch more area, I can put this point up here instead. And unfortunately, ASCII art is not going to work quite as well for this. But I would just connect this down to here and make a big triangle, really tall triangle, rather. And that would account for all of our area. And so there are some cases to deal with here. There are 3 directions that the big triangle can go in. And this, luckily, the zigzag pattern does take care of the no straight angle edges. whereas my original construction didn't. Yeah, that's basically what I'm doing here. It just takes a little bit of casework, handling all these cases and then uploading that. So that's it. That's how I did each of these problems, and I will see you in the next one.